All right, so the question that we're going to solve is this. So remember, things that you need to know about the x-intercepts. The x-intercepts mean three things. Find the x-intercept, find the zeros, solve the quadratic. That's what you need to know. All right? So for this one, the first thing that we're going to do is we have to get it to solve it, to find the zeros, or to find the x-intercepts, we have to get it in standard form. We have to have it set equal to 0. The reason why we have to have it set equal to 0 is because the y value for every x-intercept is 0. So what we're doing here is, if I want to get this in standard form of this would be negative x squared plus 10x minus 24 equals y. That would be the standard form. And since I'm moving the 24 over, 24 minus 24 creates a what? A 0. So where on my standard form is that 0 located? In the same place as the y. So it's saying that the y value for these x's is 0. That's the reason why. Okay? Now then, so in this, since this was put on a worksheet that said factor quadratics, we know it's going to factor. But I'm going to use the discriminant to show why. Okay? And so the discriminant, b squared minus 4ac, my b is 10 squared. Okay? My 4 stays the same. My a is negative 1, and my c is negative 24. Okay, so this is going to be 100, and it's going to be 4 times negative 1, which is negative 4. What's negative 4 times negative 24? Calculator people? Anybody help me out? Who? 96. Positive 96, correct? So I got 100 minus 96, which is? 4. What kind of number is 4? First of all, it's whole, right? It's not negative. Okay? It's a whole number. And so therefore I'm going to have two x-intercepts. And since it's a perfect square, then I'm going to have what are called two rational exponents, which means that it will be a non-terminating, non-repeating decimal. So this will be 2 rational, and we're going to solve it by factoring. Now, you don't necessarily have to factor this. You can use quadratic formula, but you're still going to come out with 2 rational roots. Okay? Now, you had a question exactly like this on your test, to where it had the leading coefficient as negative, and it really created problems for your factors. Okay? And the reason is because this technically has a number for a. That's not 1. It has negative 1 is technically your number for a. And so since that happens, what you need to do is you need to take your a and you need to multiply it to your c. Okay? Because this negative on this x, when I break it down into factored form, is playing a role on the other numbers instead of just a number times itself. It says it's just a number times 1. Okay? And so what's going to happen is we're going to multiply everything through by negative 1. Alright? And so when I do that, this is going to become that right there. So negative 1 times negative x squared is x squared. Negative 1 times positive 10x is negative 10x. Negative 1 times negative 24 is positive 24. And negative 1 times 0 is still 0. Okay? And so now I can ask those questions of, what do I multiply to give me 24 and add to give me negative 10? Okay? Now, some of you are like, well, I'm not going to use the factoring. I'm going to go ahead and either use the calculator or I'm going to use quadratic formula. I'm not worried about that factoring stuff. That's too hard. You had that option when we were just finding x-intercepts. But we're fixing to be moving into a new unit of polynomials. And in there, you're going to need to have the ability to factor, because that's what you're going to have to do with something higher than a square. So you don't necessarily going to get to hide from the factoring concept. So we might as well jump into it with both feet. All right, so what are those two numbers? We have a 6 and a 4. That gives me 24. But down at the bottom, I need it to be negative. All right, negative 6, negative 4. Does it matter which order? Can I put negative 4, negative 6? Can I write them in that order? I can. What property does multiplication and addition have that allows me to do that? The commutative property. The commutative property. And that's the reason why the factoring stuff works, is because I can move things back and forth. Okay? Now, one thing I want to take a little excerpt and teach right here and not just finish solving the problem. Let's pretend that we have that. Is that factored form? We have an A and a B, so it represents any number I want it to be. Is that in factored form? Okay, so what I want you to see is this is our goal. That's the goal at the end of this. Okay? And so what I want to show you is what I'm about to do. You need to see where that step comes from. Because what I'm about to do is I'm about to take the negative 10 right here, and I'm about to replace it with negative 6 and negative 4. And I hope you go, why'd you do that? Or, why can you do that? And so I'm going to show you with these numbers that are A's and B's, because they can be any number I want. Watch what happens. If I multiply this thing out, that's going to give me x squared, okay, and it's going to give me plus xb. And I'm going to do it with my a. That's going to give me ax, and that's going to give me ab. A and b are going to create a factor, right? This is multiplication. Do you agree with that? In here, what's common between xb and ab? The x is, right? So I can combo those, and when I combo those, I get plus a, or b plus a times x, because I don't know what a and b are, plus a and b. And so this portion right here where I said, what two numbers multiply to give me 24? Well, this is where my 24 exists, and that's multiplication, is it not? So that's why I can ask that question. And add to give me negative 10. And so do you see what's happening right here? Is that addition? Is that addition?
Yes.
And so that's why those two things happen. It's not like I created something out of thin air. Okay? And so inside there, that's what happens. And here's what else you need to see. This part that we did right here, where we did xb and ab, that's what's going to allow me to split it. So now I've taken my factors, I'm going to bring them back in, I'm going to plug them in as negative 6x, negative 4x, plus 24. This is the exact same thing as that right there. Instead of condensing it, I've expanded it. Okay? So, here's my groups. Because some of you, all you're going to do is you're going to just get wrapped up in the factor by grouping and roll with it. But you need to know where it's coming from and why. Okay? What's common in the first one? What's the GCF in the first one? X squared minus 6x. X is. So the x is going to come out, and I'm left with x minus 6. What's common in the second one? 4 is, correct? And since 4 is, I have to write it to where it will be x minus 6. So I don't need to factor out a 4, I need to factor out a negative 4, right? And that will leave me x minus 6. And so therefore my factored form is x minus 4 and x minus 6. Could I have written it as x minus 6 then x minus 4? I could have done that because that one multiplication is commutative property. All right. Now, yesterday we talked about writing the equation of a quadratic given the zeros and the 2 points, well, the zeros here are 4 and 6. Here's where they come from. X minus 4 equals 0. X minus 6 equals 0. And so x equals 4 because I added 4 to both sides, and x equals 6 because I added 6 to both sides. So yesterday when I would give you this 4 and 6 and you had to write the equation, we had to rework it backwards. And so if the vertex or if the intercept is 4, how was that written in factor form? Well, it's x minus 4 because to move to the other side I had to add it. Okay? Do I need to go through and do the vertex concept? Do I need to see how I got that? Just did it in the calculator for the maximum or minimum, and this has a maximum because it has a -1 on it.